right, today we are scooting back to lesson 1.4. 1.4 talks about properties of real numbers. Your learning target today, I can identify and simplify expression using properties of real numbers. Do you want to know a cool way to represent real numbers is 2 lines for the R, and you go like that. That represents a mathematical world. That means all real numbers. Okay? And that's what we're learning today. We're learning that's the irrational numbers, that's the rational numbers, that's everything in the universe. Okay? Vocab associated with this today. Properties all has to do with making equivalent statements. So you need to know what equivalent means. It means 2 statements that are the same.
I knew it.
2 statements that are the same. That's the only vocab word associated. But now we need to know properties, and this is nothing new. You have learned properties since 6th grade. We talk about properties. Okay? Commutative. Commutative property, you just switch the terms around. Commutative property, you just switch or flip, whatever you want to call it, the terms around. For example, if we had A plus B, it's the same thing to switch them and call it B plus A. Commutative. Commutative property. Only works for addition and multiplication. I'm going to write add / the asterisk means multiply. Okay? Associative property. All associative means, I always look at this root word like associate. And associate, I think of like a group, and if you think of your group of friends, you're kind of in close together. So anytime I see parentheses moving, it tells me it's an associative property going on. So all we do is move the parentheses to different terms. Terms is a part of an expression. I guess that's like a vocab word. It's a A, it's a B, it's a C. You move it around. So different things there, it's becoming a new group. Different things need to be inside the group. Okay? For example, if you have A plus, look at B and C are part of a group. B plus C. It's the same thing as moving the parentheses to A and B being in a group and C on the outside. Okay? So anytime that you see things inside the parentheses moving, different things inside there, that's associating. Different letters are associating together. They are part of a group. Okay? Only works for addition and multiplication. I flipped that. I applied the commutative property there. Notice? Okay, so, got it? Identity. The value stays the, what do you think? Same, good job. Identity, the value stays the same. Example, and this again is a multiplication and addition situation. If I wanted to stay the same and I was going to add something to 5, what would I need to add to 5 to stay 5? 0. So 5 plus 0 is equal to 5. That's identity. If I had 3/5 and I wanted 3/5 to stay the same and I wanted to multiply it by something, what would I multiply 3/5 by? 1. So anytime you see adding 0 or multiplying by 1, it's an identity property. It's staying the same. Okay, ready for this intense one? 0 property. Oh my gosh, what's going to happen here? The expression turns to
0.
0. Wow, genius. 0. the expression turns to 0. So you have addition and multiplying again. Okay? Addition you would be like adding its additive inverse, right? 5 plus what would give me 0? Negative 5 gives me 0. So if you add the opposite of what it is, it's going to give you 0. Negative 3 plus what? Yep, gives me 0. 4 plus what? Negative 4 gives me 0. Now let's go move to multiplying. 3 times what would give me 0? 4 times what would give me 0? So with multiplying, if I times by 0, the answer will be 0. And adding, if I add its opposite, the answer will be 0. Multiplication property of negative 1 is definitely a biggie. It's one that you are assessed on quite frequently or that you should just know and become familiar with. If you multiply things by negative 1, all you're doing is changing the signs. Changing sign. So you're going from positive to negative or from negative to positive. And how you do that, if I tell you to change the sign, you multiply through by negative 1. Let's say, for instance, negative x is equal to 5. X is not alone. Remember, in algebra, we always want x alone. Since x is not alone, I need to get rid of that negative. I need to change its sign. Well, if I need to change its sign, I multiply through by negative 1. So here I would multiply this through by negative 1, times it by negative x. And in algebra, what you do to one side, you need to do to the other. And we get negative 1 times like a negative 1 is just positive. I never go that in depth. I just know that I change everything. So if I had negative x is equal to 10, I'd say x is negative 10. Okay? If I had negative x is equal to negative 3, I would say x then equals positive 3. I just change everything. Do you see? Negative x is equal to negative 57. X would equal a positive 57. That's all applying this property. Technical part of this property is this first part I explained. It's a little on the complicated side, so I just know if I want to change the sign of everything. That's the multiplication property of negative 1. Okay. We're going to work on identifying some properties. When we're identifying properties, I always just kind of look at both sides here. X plus 0 is x. So my x stayed the same. It didn't change. This would be identity. It kept its identity. 3 plus, this next one, the quantity 5 plus x is equal to 3 plus 5 plus x. I look here, I see 5 and x are associated together, and then all of a sudden 5 wanted to associate with 3. That tells me it is associative. Anytime you do a regrouping or move parentheses, it's associative. 10 times x times 0 is 0. I see an answer of 0. That tells me right away it's going to be a 0 property. 5 plus 2x equals 2x plus 5. It looks like comparing them, I just flipped the terms around. That is a commutative thing. And lastly, y times 4 is equal to 4 times y. Again, I just flipped the terms around. That's the only change that happened. That is a commutative situation. Going to the next page. We are going to use properties to do mental math. Okay, using properties to do mental math, we always want to group facts that we know. And we know things that have to deal with tens. And we know things that have to deal with 25s. You want to do fast facts, something that you can do as fast as possible. When I'm dealing with addition, I definitely look for 10s. I look for those ending digits that end in 10. I see a 7 and 3 could add together to make 10, so I'm going to add those two up first. 7 and 3 is 10. I would carry a 1 to the next spot. 2, 0, and 1 would be 3. Done with that. 1 and 1 is 2. And then I add that last number. That can easily be done. 0 at the last. 5 and 3 is 8. 4 and 2 is 6. Much faster when I group together with a 10. Okay? 4 times 6 times 25. I see 4 and 25 is equal to 100. 100 times 6 is 600. Next page. We're going to simplify expressions using properties. All right. So, associative property multiplication tells me that I can regroup this as 4 times 3 times x, which is 12x. You don't have to go through that part. This is just applying the associative. I can just say, okay, I know I'm multiplying, so I can do whatever I want. 4 times 3 is 12. Throw the x at the end. Okay? Same thing in the second one. It is addition with grouping. I can apply the associative. I can put the 8 in here and throw the 7b out. Because now I'm going to say 4 wants to hang out with 8. So I could rewrite this as 4 plus 8 plus 7b. 12 plus 7b. That is it. I cannot combine them because there is not a b next to the 12. Okay, they are not like terms. We haven't reviewed that lesson yet, but you need to know. You can't combine things that are not alike. 6 plus 4h plus 3. Now, I'm not going to show you the major regrouping here, but I just know I can add any way I want. So I can go 6 plus 3 is 9 plus 4h. Can I combine them, class? No. Why can I not combine them? There is no h on the 9. If there was an h on the 9, I could combine them. So I leave it like that. The last thing we're going to deal with today, is simplifying fraction expressions. What you want to do when you simplify fraction expressions is cross out any common factors. Cross out any common factors on the top and bottom. So I'm talking about the top and bottom. If they have the same thing on the top and bottom, cross them out, they cancel. Okay? And then we also, so it's kind of like this. First, do this. Second, simplify the coefficients, which means numbers. If I have 12x over 4, I can't really cross out any x's or anything like that. So I'm going to jump right to the second step, simplifying the coefficients. What's 12 over 4? What's 12 divided by 4? 3. 12 over 4 is just saying 12 divided by 4. That's 3. Throw the x at the end, 3x. 12x over 4 would be 3x. You just go 12 divided by 4, put the x at the end. X over 3x. Uh-oh, I have a common factor of x. They cancel out. So what's left, this is not a 0 here. This is a 1. There is a 1 on top. This turns into just 1 over 3. Okay? Not 3. Many students are going to pretend to put 3. They're going to throw that 3 on the top. Don't be one of them. There's a 1 on top. There's not a 3 on top. 6xy over 2y. I can apply both steps. First, cross out what they have in common. What do they have in common? Y. Cross it. Done. Y. I'm over you. Done. Okay?
I'm not over Y.
Secondly, I'm going to deal with the coefficients. What's 6 over 2?
3.
6 over 2 is 3. So I rewrite that as 3. What's left over? X. I have that x left over. That turns into 3x. Done with our property lesson.